In this lesson, we are going to talk about graphing a line from an equation in standard form. And then we are also going to talk about graphing horizontal and vertical lines. So those are your flat lines as well as your straight up and down lines. So let's start by talking about the quick graph method. This is going to be new. So standard form is when you have a line in the form ax plus by equals 0. And if you remember from before, we have been graphing lines that were in slope-intercept form, and that is y equals mx plus b. So this is a little different. We can't just find the slope and then graph it. So what we have to do is find the x-intercepts and the y-intercepts. So if we start by finding the y-intercepts, we're going to let x equal 0 and then solve it for y and get that ordered pair. And then we put that on the axis. And then we do the opposite thing where we're going to find the x-intercept. And that's where we let y equal 0 and solve for x. Then we'll find that ordered pair and put it on the graph. So let's try one. So here we have this equation, 6x minus 2y equals 6. If I want to find the y-intercept, what am I going to substitute first? We're going to substitute for x, that x equals 0, right? If we're starting with our y-intercept. So that means I'm going to say 6 times 0 minus 2y equals 6. And then we simplify it. Well, what is 6 times 0? It's 0. So really we can say that cancels. Then I'm left with negative 2y equals 6. What's happening between the negative 2 and the y? They're multiplying. What's the inverse of multiply? Divide. So I'm going to divide by negative 2. So I end up with y equals, these cancel, a negative 3. So what's my ordered pair? Well, we know that x was 0 and y is negative 3, so our point is 0, negative 3. Let's go find the x-intercept. If I'm finding the x-intercept, what am I substituting? Y equals 0. Remember, it's always the opposite. So I'm going to take that same equation from up here, 6x minus 2. I'm going to take out the y. I'm going to plug in 0, and then we simplify. Okay, what is negative 2 times 0? It's 0, and so it cancels. So then we're left with 6x equals 6. We're going to divide by 6, and we get x equals 1. So what would be my ordered pair? Well, x is 1, and y is 0, right? So there's my x-intercept. Let's go put these on the graph. If I start with that x-intercept, am I going up 1, down 1, left 1, right 1? We're going right 1 space. And for my y-intercept, am I going up 3, left 3, right 3, down 3? We're going down 3. You've just got 2 points, and then we are going to graph our line. Try to make it, because you've only got 2 points, we've got to try to make it as accurate as possible through those 2 points. So I highly suggest using your straight edge or your ruler. We could graph this by solving for y and putting it into slope-intercept form. What's slope-intercept form? It's y equals mx plus b, which is why we want to solve this for y, right? So if I take 6x minus 2y equals 6, and I want to solve for y, do I want to inverse the 6x or the negative 2 first? We always start with the piece that's separated from the y with a plus or minus sign, so that would be the 6x. If this is a positive 6x, we're going to inverse it with a negative 6x. bring down the negative 2y. And over here, if I want it to be in the form mx plus b, do I want to write the 6 or the negative 6x first? I want to write negative 6x first. These are not like terms. I know it can be very tempting to want to combine those and get either 0 or 12, but don't. We've got to put this into slope-intercept form, remember. So the last thing is what is happening between the negative 2 and the y? They're multiplying. So what's the inverse of that? Dividing. I'm going to divide all the way across. Okay. So now I have y equals negative 6 divided by negative 2 is 3, and it would be okay if you get a fraction there. We know how to graph that. Don't forget the x. 6 divided by negative 2 is negative 3. So now, does this look like slope-intercept form? Absolutely. So what's my slope? My slope is a positive 3, and my y-intercept is negative 3. So which one of those do I want to plot first? The y-intercept. And am I going to plot that on the horizontal axis or the vertical axis? Well, the horizontal axis is x and the vertical axis is y. This is a y-intercept. So we're going to go plot it on the vertical axis, down 3 at negative 3. Then my slope, I'm going to turn that into a fraction, put it over 1. So I'm going to go up 3 or down 3? Up 3 and over 1. Up 3 and over 1. And remember, when we do this, we make lots of dots to make this as accurate as possible. Okay, so we've got all of our dots, and I went backwards as well, down 3 and back 1 from my y-intercept. So then we can graph our line and put our arrows on the end. And you should get the same graph as we did in the previous example. If you look, we've got the same y-intercepts. Y is a negative 3, x is positive 1. It's just a different way to do the exact same problem. So let's try the process again. Let's look at using the quick graph method. So let's start with that 3x minus 2y equals 18. And let's start by finding the y-intercept, which means I'm going to plug in what? That x equals 0. So we're going to start with 3x minus 2y equals 18. And remember, we're plugging in 0. But what happens when you take 3 times 0? It cancels. And we're left with negative 2y equals 18. So what do I do next? We're going to divide by negative 2. We get y equals negative 9. So what is my ordered pair? Well, remember that x is 0, so that goes first, and y is negative 9. So that's my y-intercept. Now let's go find our x-intercept using that same equation, right? But this time, what are we substituting? That y equals 0. So this time I can say 3x minus 2y equals 18, and I'm plugging in 0 for y. And again, what happens when you multiply something by 0? It cancels. So now I have 3x equals 18. What do I do next? We divide by 3. I get x equals 6. So what's my ordered pair? 6, 0. So I'm going to go put those on my graph. Take a second and plot these on the graph. Let's check. Here's 6, 0. And here's 0, negative 9. Then we graph the line. And make sure we have arrows on the end. So let's go graph it Again, same line, so we should end up with the same answer. But let's try it by solving for y first, putting it into what form? Slope-intercept. Y equals mx plus b, right? Where m is what? The slope, and b is the y-intercept. So if I take that 3x minus 2y equals 18, which part do I want to inverse first? We always want to start with the term that is separated by a plus or minus sign from the variable we're solving for. So the minus sign is between the y and the 3x, so we're going to start by inversing the 3x. Are 18 and 3x like terms? Nope. Which one do I write first? The negative 3x, and then this is a positive 18, so we're going to say plus 18. I'm going to bring down the negative 2y. And what do I do next? Divide by negative 2, and remember we want to divide all the way across. So I get y equals, it is okay to have this 3 over 2 as a fraction, but we do need to reduce. Negative over negative is a positive 3 over 2x, and then 18 divided by negative 2 is a negative 9. So what is my slope? 3 over 2. What is my y-intercept? Negative 9. So where am I going to start? I'm going to start down 9 on the y-intercept. Right there. Then I'm going to count up 3 and over 2. And remember, we continue this all the way across the graph. Okay. Then I'm going to draw my line and add my arrows. And I'm going to take off all these extra dots. They are not part of my line. That was just so you could see where I was counting. And there you go. And if we look, it is the same line. I have that y-intercept of negative 9, an x-intercept of positive 6, same exact line. I do find that this tends to be a little more accurate because you have more dots, but this, the quick graph method, is definitely faster, but you get to the same answer. So you get to choose. Let's talk now about our horizontal and vertical lines. So if you go back to your front page, we have a couple of tips here for you. Horizontal lines, these are the ones that are actually functions. They have a slope of 0, and then whatever the line is will be your y-intercept. Okay? And then we have vertical lines. These ones are weird. They start with x equals. So you just kind of have to remember. Y equals has a y-intercept, and it's a vertical line. Okay? X equals means it's a vertical line and it has an x-intercept. Okay? They will not have a y-intercept. They cannot be written as y equals mx plus b. They don't even touch the y-axis. There is no y involved. We call the slope undefined. And I'm sorry, this was the wrong way. These are a horizontal line. They're flat. These are your vertical line. Okay? Let's look at some. So this one, we have y equals 4. That means our y-intercept will be 4. So am I going to go up 4 or right 4? Well, if this is a y-intercept, we want to make sure our point is on the y-axis. And then it's not going to touch the x-axis at all. So we're just going to make a completely flat line. I suggest using your ruler. Okay? Then we have this x equals negative 2. And this is an x-intercept. So I'm going to go to where x is negative 2. And you want a line that will not touch the y-axis. So we're going to make it straight. Should be all one line. Let's see. If I do it like this, it'll be better. -2, and draw your straight line with your arrows on the end. There you go. That's all it is. So why don't we try, just on the same graph, not a big deal, what if you were to graph and label y equals 3? Well, this is a y-intercept, so you're going to go up to 3, and then it is a flat line, a horizontal line, like this. And when I say label, we just put a little label on the side. Why don't you try graphing x equals 5? Well, that's an x-intercept, so we're going to go to where x is 5, and then we draw our line and put the arrows on the end. And again, we label it. There you go. Simple as that.